Good morning. Well, it's morning for me. Uh, had a question about this one. This is from exercise 4B, measurement errors. So, quickly go through a couple of these ones. We'll probably talk about it in class, but only briefly. All right. So, four measurements of length are shown on the ruler below. We've got A, B, C, and D. There they are. What length is indicated by each letter? Answer to the nearest millimetre. So you can see they're pretty much all bang on. They haven't indicated, but this ruler, I'm assuming, is millimetres because, well, that's an assumption, but it's probably accurate. So A would be 10 millimetres, B would be 44 millimetres, C would be 72 millimetres, and D would be 89 millimetres. So I'm assuming probably most of you are all right with that. That's not a problem. But now what it's looking for is the other stuff that we've been talking about. So the precision or limit of reading. So because we're assuming that this is in millimetres, then the precision or limit of the reading is 1 millimetre. So we can't get any more accurate than 1 millimetre. What is the largest possible absolute error? Well, remember, it is plus or minus half of the precision. Okay, so that means it is plus or minus half a millimetre, or plus or minus 0.5 millimeters. That means that's the absolute error they can get. So if I'm measuring this one that I said is 10 millimeters could possibly be 9.5 millimeters, but it could also possibly be up to about 10.5. So it's somewhere in between there, even though I'm reading it as 10 millimeters. So what is the upper and lower bound for each one? So for A, we've got 9.5 to 10.5 millimeters. For B, we've got 43.5 to 44.5 millimeters. For C, we've got 71.5 to 70, that's a 9, 2.5 millimeters. And then for D, we've got 88.5 to 89.5 millimeters. So what we've done is we've gone plus and minus from our actual measurement, and that is our bounds. Okay, so calculate the relative error. So I'm going to do these ones down here because I'm going to run out of space otherwise. Calculate the relative error correct to 3 decimal places. So the relative error is our largest possible error over our actual measurement. So what we've got is we have 0.5. So we'll do A first. So we've got 0.5 over 10. Okay, so 0.5 over 10. You guys can't see, but I'm bringing up a calculator because, well, I can. That's not what I wanted. So 0.5 divided by 10 equals, okay, so these are our relative errors, equals 0.05. For B, give me 2 seconds. Sorry if there was a glitch there. I just had to pause for a sec. Sorry. So B. So that was the relative error for A. So we've got the absolute error over our actual measurement. For B, our relative error is still the same. Our absolute error is still the same, 0.5, but our measurement this time was 44. So when I put that into a calculator, I've got 0.5 divided by or over 44. And we want to do it correct to 3 decimal places. So this one will be 0.11, so 0.11. And don't forget, these are plus or minus. So these are, well, actually, I'm not even going to bother. I'm just going to say it's 0. These are relative error. So C, we've got 0.5 over 72. And for D, we're going to have 0.5 over 89. They've all got the same absolute error. So all we're doing is calculating the relative error by dividing it by what our measurement was. So 0.5 divided by or over 72 and 3 decimal places, that will be 0.0 0.07, if I'm not going crazy. I'm not going crazy, but the previous one, I'll just do that again because I just realized that I didn't actually do it to 3 decimal places. It's 0.011. There we go. 0.11. Sorry, I had to double check myself. And I'll just do the first one again, but I'm pretty sure that it didn't need to have 3 decimal places. No, it didn't. So if I wanted to put it to 3 decimal places, I could add the 0, but it doesn't really matter. Last one, 0.5 divided by 89, 0.006. So that is our relative error. Now, our percentage error is just our relative error multiplied by 100, and that gives us 8%. Okay, so these ones I've got 0.050. If I multiply that by 100, I'm going to be moving the decimal place 2 spots. So I'm not going to bother using a calculator because I know what I'm going to have to do. So that would give me a 5% error for A. For B, I'm going to move the decimal place 2 spots again. That would give me 1.1% error. For C, 1, 2, 3, it will give me, 1, 2 spots would give me a 0.7% error. And then the last one would give me 0.6% error because I'm multiplying that by 100 as well, which means the decimal moves twice. And that's it. That is the percentage error. So these are all the same sort of thing. What is the length indicated? So we have a look at it and go, okay, that's our measurement based on what we can see. The precision is the smallest increment that our measuring device gives us. The largest possible absolute error is half of that precision, plus or minus. Then the upper and lower bound are just take your measurement and then take off the absolute error. So take off the absolute error, add the absolute error, so that's the plus minus. The relative error is that absolute error divided by the measurement that we took. And then the percentage error is just taking your relative error and multiplying it by 100 to turn it into a percentage. I hope that helps.